Hello friends, in this video we are going to continue the same problem which we have discussed already in last two videos. So we have seen first brute force approach, so where the time complexity is order of n square. Next we have seen the sorting approach where its time complexity is order of n log n. Now we will see another approach where its time is so less than n log n, and that approach is nothing but a hash map approach. Right. Now here I have created one table. Now the table is containing two fields, friends. One is I'm going to call it as a key, and other I'm going to call it as a value. Now I'm going to take the first element 3. Now I'm going to check initially. So this table I'm going to call it as a hash map. HM is nothing but a hash map. So it is one data structure. So it's a kind of key value pair based data structures. And in Java collection framework, we call it as a hash map. Now, first I'm going to take element 3. I'm going to check. Does it is present? Not present. So since it is not present, so I'm going to take this value key and I set first time its value to 1. Similarly, I'm going to take next time this 3. Now I'll going to search. 3 is already available. So hash map is designed in such a way that the search time is going to take order of 1. That is the advantage of the hash map. So they are designed as such in a way that so it is going to take in order of 1 time, constant time. Alright. Now again I'll take element 3. So it is already available. So once that element is already available, I'm going to take this value, right? And then I'll increment this value by 1, and again I will try to put it back here. That is what I'll try to do. Right. Now next 4. Because 4 is present first time, so I'll set this value by 1. Similarly 2. 2 is also not there, so I'll take this and I'll set this value here. Next 4. 4 is already available. Now I'll take this value backside. And I'll increment it by 1. So initially 1, I'll increment it by 1 and I'll again keep it back. Now while doing like this, so maybe what I can do here is, so after taking this value back and incrementing, now I'm going to compare that element, friends. Does it value, whatever the value you have taken outside, after incrementing, is it really greater than n by 2 plus 1? If yes, better I'll take that value and print and I'll stop the process. Because we want a majority element that should present at least n by 2 plus 1 times. Correct. So this value, it is representing frequency. Therefore, after taking that value and incrementing by 1, now I'm going to check, does it really present minimum these many times? Then happy, then I got a majority. So once you know that it is majority, then why to waste time on the remaining elements? I hope you are getting. Therefore, let's say if element 4 is present continuously, right? After completing a half of the array, obviously if it is present 4, 4, 4 at single stretch, then I'll get by traversing half only, right? Now I'll show that, maybe I'll write the code parallelly and I'll explain so that you'll get the more clarity. So you see the code, so they have given a function where it is taking input array and number of elements as 1. So first I'm going to, so declare one hash map. So maybe this is a syntax in Java. Any language, whichever you are comfortable, you can please go with it. So integer, integer. So maybe I'll be taking its name as HM. So new hash map of integer. So, yes, I have declared one hash map. Good. Now I'll be taking one simple for loop. So int I is equal to 0, I less than n, I plus plus. Now, so once you write this line, so what will happen, friends? So hash map will be, so we can see hash map like this, and it is containing two fields. One is key and another is value. So this you can call it as key, and this you can call it as a value, and initially it is empty. Now I'm going to take this value. Now I'm going to check. So now the name of the hash map is HM, right? So I'll check, does this 3 is present here? If yes, I will take this outside and I'll increment and I will put it back. The moment when you are putting back, you please check that does it really appear n by 2 plus 1 times or not. If yes, then stop the process. For the first time, now I'm going to check if, so I have one method here. So hash map is having a method, so contains key method. So what it does, so it is going to check, does that element is present or not. Contains key. So where I will be passed that input array of I. In case if it, so it basically it returns true or false. If it is returning true means that element is already present. Okay. So if that element is already present, I'm going to do something. If that element is not there, so else, okay, I'll talk about if case. In case if that element is not there now, then you need to add, which means you have to put that array of I, okay, comma, just 1, because it is not there now, so you are setting its frequency by 1. Okay, in case if that element is not present, what we should supposed to do? So first time when I is at here, so since 3 is not available, so this if condition will become false. Now this 3, okay, this 3, we will keeping that array of I and we are setting its value to 1. Next, now this 3. Now again I'm going to search. Now this time if you see hm dot contains k array of I, now it will return true, friends. Why? Because if 3 is present, right? So once it returns true. Now it returns true. Now I'm going to take this value outside. Okay, I will take this value. So I'll be declaring one variable. So let's say int freak. Okay, or maybe I'll take one variable called frequency. This frequency is equal to hm dot, which means I need to get that value. So get, I'll be passed the input array. Okay, in case if that element is there, I'm going to take that value and I'll try to increment that value by 1. After incrementing, I told you need to again add that value to the hash map. So whatever that frequency is there, so array input array of comma, you add whatever this frequency. So frequency of that array of I. So you add it there. But before adding, I will say, okay, you check this value, friends. In case, for example, if whatever the frequency that you got, let's say here, frequency, does it really greater than n by 2? In case, if this is true, which means we got that output, right? So then you can write happily return array of y. So why to waste the time once you know, right? In case if this is not happening, then you put element back. Okay, so let me complete this one. Okay, now when I is at here, now see carefully, when I is at here, now 3 is already available. So I'll take this frequency, how? By using a get method. So hm dot get array of I, so it will use that element. Now I'll do +1. Why +1? Because you found that element one more time, so its value will be 2. Now I'm going to check, does 2 is enough to say yes, it is a majority when array of elements are 9? No, it is not enough. Then I'll, in case if this if condition false, now I'll put this value backside, which means 3, then this value is going to become 2. Next, I now 4. For the first time, I'll take this, I'll set this value 1 here. Next, 2 is first time, so I'll take and I'll set this value 1. Next, 4 is second time, so I'll take outside and I'll increment it by 1, then it is going to become 2. Now 2 is not enough to say majority, so I'll put it back again. Now 4 is already available, so I'll take this value outside and I'll increment it by 1, 3, but I'll check, does 3 is enough to say majority? No. What is a number is enough? What is the minimum number is enough to say it is a majority? Minimum number means frequency 5, minimum 5. Okay, because n by 2 will be 4 plus 1 minimum. So remember, this is minimum, friends. Okay, but 3 is not enough, so I'll put it back 3. Next, I, which is 2. Okay, now 2 is its frequency 1. I'll take and I'll increment 2, and 2 is not enough to say majority. I'll again put it back. Now I 4. 4 is there. You take 3 outside, plus 1, 4. 4 is not enough, so put it back. Next, I 4. Okay, 4. I'll take 4 outside, plus 1, that is 5. Does 5 is enough to say majority? Yes, happy. Then you can return array of I value as a majority. Then you don't need to even put it back also, because when you write return here, so when you write return, so automatically, so this will be written that value which is 4, friends. Okay. For example, once if the whole story was over, if it is not returning anything, which means majority you didn't found that. Okay, so with this for loop will be completed. In case if it is not available, so now you can write simply return -1. You can write simply return -1. Okay, cool. Because compiler is expecting you to return some integer value, right? So whenever if it is not available, you can simply write it's -1. They'll mention it in the question. So what value you just need to return. So don't worry on that. Okay, so now idea is to here use the hash map. That is the idea here. Okay, now let's analyze the time complexity. Now you see this for loop is running n times. So this for loop is going to run for n times approximately. Now this contains key, okay, this get method, put method, everything will work in order of 1 time. So that is the beauty of this hash map. Okay. Now since all these are going to take order of one time, so asymptotically, so all these will take order of one, and loop is running n time. So overall n into 1. So its time complexity is order of n. So its time complexity is order of n. What about space complexity? The space complexity is interesting, friends. So space complexity, worst case, it is going to take order of n. I'll tell you how. See, when array all elements are distinct, for example, if n is equal to 9 and the elements are, let's say, 1, 2 and so on 9. Now, don't you think that our hash map size is going to be as good as the array size? Yes, because every element you need to find out its frequency and you need to store it in this table. So table, I mean to say, it is a hash map. So first element is 1. So 1 is present one time. Next element is 2. So it is its frequency 1. Next element is 3. Its frequency 1. Like that 9. So which is 9. So here in the worst case, our hash map size is going to become as good as the array size. So in such case, the space will be order of n. Space will be order of n. What will be the best case the space will be? Let's say if that element present all the time, which is all elements are same, which means 1, 1, 1, 1, 1 like that. So number of entries in hash map, in this case, only one entry 1 and it appeared 9 times. Whereas in this case, 9 entries are there. In this case, only one entry. But always we have to give in worst case only. Therefore, the space will be order of n. So 3 approaches we have seen. One is brute force approach n square time. Second is sorting approach n log n time. And the third approach is hash map approach where its time is order of n. Now we have the fourth approach where we need to optimize the space to order of 1. Okay. So in the next video, I'm going to discuss about fourth approach, friends. Okay, so meanwhile, you can think of how can we optimize the space complexity. Of course, time you can't optimize. Optimization can be performed on space only. So maybe you can think of, and I'll discuss this solution in the next video. Right? Okay, so thank you.